In example 3, we are looking at two equations in Cartesian coordinates, and we would like to know what would they look like in cylindrical and spherical coordinates. So to convert x squared plus y squared plus z squared equal to 4 into cylindrical coordinates, we remember that x squared plus y squared, that is the same as r squared. And so we can take that x squared plus y squared, replace it with r squared, and we come up with r squared plus z squared is equal to 4. And that's our answer. Looking at spherical coordinates, x squared plus y squared plus z squared, we can replace that with rho squared. And so here we are getting the equation rho squared is equal to 4. And since rho is always positive anyway, we can replace it with rho is equal to 2. And that would be the easiest way to describe this surface in spherical coordinates. And I would say that answer wins. It's the easiest one out of the two. It really looks the least complicated. In part B, we are looking at x squared plus y squared minus 2z equal to 1. And in cylindrical coordinates, again, we can use the fact that x squared plus y squared is r squared. And so we are getting r squared minus 2z is equal to 1. And solving for z, we can rewrite this as r squared minus 1 over 2. And that's our final answer here. For spherical coordinates, there isn't anything obvious that we can do, so we can go to our conversion table and just brute force what is x equal to, what is y equal to, what is z equal to, and we remember that x is rho sine phi cosine theta and y is rho sine phi sine theta, so x squared plus y squared can be replaced with those other two quantities squared. And then z was rho cosine phi. And so we're getting this somewhat complicated looking equation. Now, if you remember your trig equations, you may remember that cosine squared theta plus sine squared theta is equal to 1. And we can actually factor that out out of the first two terms. And so we can replace the cosine squared, what I just underlined, theta plus sine squared theta with 1. And so this simplifies to our final answer, rho squared sine squared of phi minus 2 rho cosine phi equal to 1. Looking at those two answers, the first one looks a little simpler, so I would say that one wins in this case.